All right, hey y'all. Today we're going to work on function rules. Yesterday we determined the output by using a rule. So they gave us the rule to use and we were able to figure out the output. So now we are going to be getting the numbers for the input and output, but we have to figure out the rule. So our essential question is, how do patterns and numbers help determine function rules? All right, so there's a couple of vocabulary words that we need to know. First one is an arithmetic sentence. So an arithmetic sequence, not sentence. Arithmetic sequence can be found by adding this or subtracting the same number. All right, an example of that would be, let's say I had these numbers. So here's my list of numbers: 7, 14, 21, 28. Okay, I got to figure out how to get from one to the other. All right, so how do I get from 7 to 14? I could times by 2, but if to get to 14 to 21, multiplying by 2 doesn't work. So I got to figure out how to get from 7 to 14, then 14 to 21, and 21 to 28. The only way to do that is to add 7. So our rule then is plus 7. So I could keep going by 28 plus 7 and get the next sequence number. All right, the second vocab is a geometric sentence. Sequence, not sentence. A geometric sequence can be found by multiplying, and in some cases dividing, the previous term by the same number. Okay, for instance, I have 2, 4, 8, and 16. So I need to get from 2 to 4, 4 to 8, 8 to 16. How do I do that? I can add 2. 2 plus 4, or 2 plus 2 is 4, but 4 plus 2 is not 8, so that's not going to work. So I have to multiply by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So my rule then is 2x. All right, let's try one more. All right, my next one is 4.5, 4, 3.5, 3. All right, so what do we notice about these numbers? All right, we've seen them going up, right? And we know that that is addition or multiplication. But in this case, we're going down, 4.5 to 4, 4 to 3.5, 3.5 to 3. So if I'm going down this way, I'm going to subtract or divide. All right, so how do I get from 4.5 to 4? Well, I subtract 0.5. 4 to 3.5, again, I'm subtracting 0.5. 3.5 to 3 is subtracting 0.5. So my rule then is subtracting 0.5. Okay. Now let's look about how that looks in a table. All right, to find a rule, you got to find the pattern between the numbers. Okay, so let's say I have an input here, which is my x value. and my output, which is my y value, which you'll need because eventually we're going to graph them. All right, so let's take a look at our data. All right, so I have 1, ay Dios. I have 1 and 3, 2 and 6, 3 and 9, 4 and 12, and we don't know what the x is. Okay, so how do I get from 1 to 3? I got to figure out how to get from 1 on the top, the input, to get to the output. So I want to get from the input to the output. So I have 1 to 3, which I can add 2. And I have 2 to 6. So if I add 2 here, that'll be 4, not 6. So I can't add 2. So 1 to 3, 2 to 6, 3 to 9, 4 to 12. All right, if I know my multiplication, I can realize that that is multiplying by 3. So it would be 3x. And that would go here. All right, let's do one more. I, which is x, output, which is y. All right, here's another set of data. I have 2 to 12, 2 to 12, 3 to 18, 4 to 24, and 5 to 30. All right, how do I get from 2 to 12? I can add 10, but 3 plus 10 is not 18, so I'm not going to add. Numbers are going up, so the only other option is to multiply. So I can multiply by 6. Therefore, my rule is 6x. Okay, those are pretty easy to do. What we're moving on to is not so easy. All right. Okay, so the ones that we are moving on to, not so easy because they are two-step equations. So they're going to look like 3x minus 4. Okay, two-step equations. All right, so let me draw our Cornell lines. All right, the table below, which I'm going to draw, shows the number of necklaces Ari can make in a certain amount of time. And we need to find the rule. All right, so here's my table. Oh, that's supposed to be hours. And the number of necklaces. All right, so number of hours, number of necklaces. All right, so in the first hour, she was able to make 5 necklaces. In the second hour, she was able to make 7 necklaces. In the third hour, she was able to make 9 necklaces. So we need to figure out what the rule is so we can figure out what the rest of the pattern is. All right, so can I get from 1 to 5? Can I get here? I can multiply by 5, but 2 times 5 is not 7, it's 10. I can add 4. 1 plus 4 is 5. 2 plus 4 is 6, not 7. Okay, so I got to look at the other data. So what I'm going to look at is here. How do I get from 5 to 7 and then 7 to 9? All right, so this is where it gets a little confusing. I can't multiply to get from 5 to 7 or 7 to 9. The numbers are going up, so my only other option is to add. Okay, 5 plus 2 is 7, 7 plus 2 is 9. All right, whatever you put here is going to turn into a multiplication problem. because I have to do something to x, which is this, to get to the number of necklaces. Okay, I can't just ignore the hours because that's important. So if I multiply 2, so if I put 1 in for x, so 2 times 1 is 2, but how do I get from 2 to 5? It's going up, right? I can't multiply. 2 times nothing multiplies to get to 5, so I'm going to have to add. So 2 to get to 5 is plus 3. Let's see if that works for the other ones. So 2x, so if I'm going to substitute 2 in for x, so 2 times 2 is 4, and I get from 4 to 7. If I add 3, does that work? 4 plus 3 is 7. So then my rule for this one is 2x, because I'm going to 2 times the x over there, and then I'm going to add 3. Okay, I think we have time for one more, so let's do one more of these difficult ones so that we can get it all. All right, let's say I had this table. All right, so we're going to work with time, which is x, and amount. So we're basically figuring out how much they can make in a certain amount of time. All right, so my data is 1 and 13, 2 and 21, 3 and 29, 4 and 37, and then we don't know what x is. Okay, so again, I can't seem to get from 1 to 13. I'm going up, so it's either multiplication or addition. So I can add 12, but that doesn't work for 2. So it's got to be multiplication. So now I got to look at this over here. So now I need to get from 13 to 21. Oh, why is this messing up for me? I need to get from 13 to 21, 21 to 29, and 29 to 37. How can I get there? I can multiply or add here, but most likely I'm going to multiply, right? Because this doesn't work with the addition. So 13 to 21. 13 to 21. How do I get from 13 to 21? That's a little bit more difficult. So the best way to be able to find something like this is, how do I get from, so I need a multiplication and then I need an addition. So I need to figure out how to get from 1 to 13 using multiplication and division. This is a two-step process. So if I can't get from one here to the other, then I got to figure out how to get from here to here using multiplication and division. I mean multiplication and addition. All right, so let's just go through some of the numbers. Let's pick like 5. So 1 times 5 is 5. And then how do I get from 5 to 13? I'm going to add 8. Okay, does that work for this? So 2 times 5 is 10. 10 plus 8 is not 21. So that's not going to work. So I need to go higher. Let's go with 7. 1 times 7 is 7. And then to get from 7 to 13, so that's 7, 8, 9, 10, 11, 12, 13. So that'd be plus 6. To get to 13. So 2 times 7 is 14, plus 6 is 20. That's not going to work. So let's go 1 higher. 1 times 8 is 8. 9, 10, 11, 12, 13. So that's plus 5. 2 times 8 is 16, 17, 18, 19, 20, 21. Booyah. All right, so my rule is 8. Okay, I got to multiply x by 8, and then I got to add 5. Okay, so again, these are a little bit more difficult. Ms. Fernley even has a hard time with these. So if you can't get it on the first try, just keep practicing and we'll work on it. And that's it. Okay, so don't forget that you have a handout to work with your knowledge check. And we'll see you in the morning.